So first, I want to give a shout out to the organizers of this conference and the audiovisual team. I usually stress the system. It's kind of fun. And they have been fantastic. I couldn't stress them even as hard as I tried. So I want to give a great big hand. This is one of the best conferences I've ever seen. So let's applaud them all. So what I'm going to, I grew up in a very small village in Sweden, in the big forest. And I could never in a million years imagine that one day I would work as the Chief Technology and Innovation Officer in a place where there are palm trees. And you can actually go in shorts during Christmas, Southern California. And then that I would have the privilege of speaking with all of you here in wonderful New Zealand. My wife is here, and when this is done, we're going to take a look at this beautiful island and your beautiful food. And after that, I won't be able to button my coat. But before we do that, I wanted to talk a little bit about what we do at Jet Propulsion Laboratory. I'm going to take you through a few examples with the hope that how we do things may spark an idea in your organizations. And it's all about energy. Yesterday, we heard from my friend Jonathan Feldman about the importance of being friendly. IT has to be friendly. We can't be naysayers. We heard from Jackie this morning about learning from others through books. And I'll have my own set of recommendations here. You're going to hear later from Tim about the government of New Zealand. And we had a chance to chat yesterday. Highly innovative. Very, very impressive. So now, let me talk a little bit. And by the way, Christian was right on. Christian and I are the same age. I just have a little more gray hair. But what he said was right on, and you'll see that through my presentation. So I wanted to talk a little bit. Does anybody remember when Curiosity landed on Mars? It's about almost 3 years ago. Okay. So what I wanted to do is I wanted to take you through the human aspects of IT, and simply put, why I work at JPL. So I'm going to play a 2-minute video of where we all were when Curiosity landed on Mars. 150 million miles away, 2,000-pound rover, completely automated. If it crashed, there's nothing we could do about it. Big risk, and IT is smack in the middle of this. So let's take a look, see if you can remember it.
Things are looking good. Coming up on entry. Vehicle reports entry interface. At this time, it'll begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do. We are standing by for guided start of guided entry. We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. We have seen peak deceleration. It is starting its first bank reversal. It is reporting that we are seeing Gs on the order of 11 to 12 Hz. Bank reversal 2 is starting. We are now getting telemetry from Odyssey. We should have parachute deploy around Mach 1.7. Parachute is deployed. We are decelerating. Heat shield has separated. We've found the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending. Standing by for backshell separation. We are in powered flight. We're at altitude of 1 kilometer descending. Standing by for sky crane. Sky crane is started.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars.
So yes, grown men do cry. But this is a decade. This is at least a decade of people's lives, and it's their passion. It's either going to fail or work in that very next second. That's what IT is all about. It's about enabling those things. It's about the excitement of what we do, not necessarily the process and all that. And that's what I'm going to talk about. When you do something like this, you have to anticipate all the risks, and in fact, other things happen that you didn't expect. So you have to be agile and be able to react. But there's a way of getting there. It isn't the big waterfall approach. It is agile, it is prototyping, and that's what I want to talk about today. Anybody know what this is? Shout it out if you do. Voyager, very good. Also known as V'ger, if you're a Star Trek fan. Voyager was created and launched in 1977. And it is now outside of our solar system, first man-made object. It's about 15 billion kilometers, billion with a B, away. It's a round-trip lifetime of 35 hours. And it had a flight computer that's inside the Voyager spacecraft. Here's a smartphone. That computer has 1 million times less storage and 1 million times less compute power than your smartphone. So what if we could take the new IT and give that to those same passionate, smart people? What could we accomplish? And that's really the challenge. So I'm going to take you on a journey to 2025. 2025 is a huge amount of time. So we break it into pieces. We're currently we look at IT decades. How long do you think an IT decade is? Yell it out. 3 years. And you can know that if we have a freshman and a senior in college, there's literally 10 years of human time between them. The new ones coming up are not going on Facebook. That's so old. But it's moving forward at a breakneck speed, and it's speeding up. So this is the CIO. It's a maestro how many are CIOs in the room? Raise your hand. Okay, lots and lots of you. You're all maestros. You're conducting this music of IT. Most of it has not been created yet. And as you think you have it correct, it'll switch from underneath you. How do you do that? Well, we look at IT decades, and we plan them, we predict them. And we've been doing this for 4 IT decades now. And what we see is that it applies to any enterprise of about 1,000 people and above, because it's the generation gap. It's when you're that big, you start getting processes and procedures that are hard to change. So I'll take you through our approach. But we look at disruptors. Is a disruptor a bad word? No. It can be. If you didn't anticipate it and you got it disrupted, it's really bad. But if you anticipated it and you could prepare for it, then it's a really good thing, because you can take advantage of OPM, other people's money. You can innovate with industry, because if you predict correctly, they will be excited about it, and you can get the benefit of their excitement in your own organization, including the people who work in your own organization. This is Johnson Space Flight Center in 1960. It is 64. You used to be able to go into the room to do computing, big disruptor. Then you could go into your own room to do computing. Big disruptor. I had one of the very first IBM ATs, and it was a fantastic thing. Now, you could go into any room. In fact, you don't have to be in a room to do computing. The big disruptor is internet. The next disruptor is the Internet of Things, or Internet of Everything. And I'm going to talk a lot more about that towards the end. But I'm now going to drive in a few examples of the current IT decade. And it is social, mobile, analytics, cloud, and then key disruptors, K. You've never heard that because I made it up. And key disruptors are really the key ones. If it has something to do with social, mobile, analytics, and cloud, it is automatically a key disruptor, but some things don't fit. First of all, let's take a look at what happens in the internet in just 1 minute. So if that music doesn't wake you up, nothing will. How is that relevant to us? Well, it's extremely relevant, because these are the industry trends that are penetrating the enterprise. And we have to deal with it. 204 million emails. They all end up in my email box every day. Actually, I did some analytics. Have you ever looked at how many emails you receive and send? I get 400 a day. I read 300 of them, and I send 100. At the same time, I'm triple booked in meetings every single day. So what does that mean? Am I Superman? No, I'm not paying attention to anything. And that's a problem. So the killer app that was email is going to be supplanted by the killer app that is not email. It's un-email. Anybody use Slack? A few of us. Go ask the startups. Anybody use Slack? I have. Everybody raises their hand, even before it was released. How about HipChat? A few of us. These things you can prototype and try in a day, and we are, to try to understand how we can communicate better and reduce the email traffic. So, social. I'm going to talk about social, mobile, analytics, and cloud. Social is no surprise, but it's not Facebook in the enterprise, not at all. It's about who's doing the work. It's about who is participating. It's about crowdsourcing. So, for instance, Uber disrupting transportations, Airbnb disrupting hotels. That will start seeping into the enterprise. Could we share the equipment that we have in our enterprise? Could we use that same model? Could we do a Kickstarter inside? Those are the kind of ideas that is going to be happening in the next 3 years, and we'll definitely be doing this. So we prototype. We tried this. Anybody been to a hackathon? Raise your hand proudly. Good. There's about 25 people. How about a maker fair? It's about 5 of us. It's really intriguing, and it's almost like a rave party for the geeks, without the drugs. And it's a wonderful thing. You can start understanding what this next workforce is going to do. This is one in Santa Monica, California, and it was 1,400 people. 4 college students put it together, freshmen in college. And it was an amazing thing. They just wanted to do it, so they did, and then we hired them. So it's a recruiting opportunity to bring in the young to participate, in our case, in space, science, and engineering. But what could they do? So this is a visualization created at a hackathon by the participants, where they're looking at soil moisture from 8 satellites across the world. And in just 16 grueling hours, they were able to produce this. And what did we learn? Well, we learned that we had to give the data in a different format, not our normal science format, but in JSON format. And then we got the feedback. We learned we had to create a sample app. So we learned a lot of things that we're now applying inside as well. So social is very important. It's also about open hardware and open software. Inside this little credit card box is a Raspberry Pi. Has anybody seen a Raspberry Pi? Wow, I'm impressed. That's unusual. Usually not that many. So here's one. And it has a motion sensor. And the motion sensor is a $3 piece. Raspberry Pi is $35. Motion sensor, $3. Put them together, put them in the ceiling in your conference room. And we did. And we were able to measure how many people attended meetings. And we were able to find out that we did not need to build a new conference room, because 30% of the meetings that were scheduled, we tied into Exchange, were not attended. So if they didn't show up for 5 minutes, we released it back into the system. So for $35, we saved thousands and thousands of dollars of creating a new conference room. Another one we use the Raspberry Pi for is, does anybody work in an environment with no windows? Luckily, there's just a few of us. What happens is you can actually give them a view to the outside. Take some unused displays, put them on the wall, dress them up like a window, and then have a Raspberry Pi and put it into some webcams, and now you have a window to the outside. So these are actually videos. They're windows into the JPL clean room or JPL outside or a beach view. And they click the button to select which ones they want, and we measure which one they want. And different people can have different ones. So it's a good way of using Raspberry Pis, but it's even better because it seeds the crowdsourcing that we're going to do inside JPL and with the outside world as well. Being mobile, social mobile. Mobile is, we discovered that by writing applications for the smartphones, we were able to get the scientists and engineers really interested. They actually weren't looking at the things we had custom created for them at lots of money. They were looking at these because they're mobile. And we use some mobile robots, telepresence robots. We were able then to, people can log in from wherever they are, participate, go roll to meetings, etc. And it was an outreach effort. But today's toy is tomorrow's tool, every single time. And in this case, it was used for this flying saucer mission, which is testing huge parachutes for landing bigger things on Mars. And the scientists were able to log in from wherever they were, Italy and across the US, and participate in meetings. They were in control. So this consumerization of IT is very powerful if we take advantage of it. Now, who in here has a Pebble watch? 1, 2, 3, 4, 5, 6. What's really powerful about the smartwatch is you can write apps for it. So we crowdsourced. You can see, if you want to see later, you can see the latest pictures from Mars on my Pebble. You can also see where SMAP, surface moisture, soil moisture active passive instrument, it's circling the Earth looking for droughts and floods, where it is at any one time. And that app took 6 hours to write. So it's changing, it's speeding up. It's remarkable. The next Pebble is the Pebble 2. It's color, it's timeline, and it's very, very powerful. Enter the Apple Watch. So all of a sudden, this mobile computing, does anybody have an Apple Watch yet, by the way? Nobody. Anybody want one? Yeah, I've seen it. It's pretty cool. But it's entering the enterprise. For us, it means that people are mobile. They're not tied in front of their laptop anymore or their computer. They can move around. Now, this is NASA a few years ago, and they are not so mobile. Now, they still need to collaborate. They still need to create. They still need to document. How do you do that in a clean room? They used to have big printers, printing 80-inch drawings. And 80-inch drawings in a clean room is not a good idea because there's dirt in printers, so they're very expensive printers. So we said, what about touch screens? And I saw at the exhibit there's a few touch screens. Highly recommend looking at it. So what we were able to do is we put this in there as, and here's the key, no added risk for the business side, the mission. They can use it if it was valuable. If not, don't use it. They used it. And then we put Apple TV on top of it, so they could put their, in that case, iPhone up to the spacecraft and see what was going on. Then we put video conferencing on it. And that stand in the middle there that we're zooming in on now is about 15,000 all in.
Attacked spacecraft.
And this is Bill Allen. He's a
And
world-renowned
areas
spacecraft,
like this
award-winning
over
spacecraft
here
designer. And let's
happen to
listen into him
know
for a second.
Are already close clearance issues. What we have here is the drawing. So I can move from the drawing environment to the model environment. An example.
So what we gave them is a window into their data, a new window. And if you notice, going back here, zooming in, what is he wearing? He's wearing Google Glass.
Attacked spacecraft.
And the power of Google Glass in this case was that you can see the world through the eyes of the expert. It's hands-free. So we then put that up on JPL Tube, which is like an internal YouTube, automatically transcribed it in Microsoft Azure, the media server cloud. And now you can search for any video for the words that were spoken in the video. So videos become data. It's very powerful, and that's tied into our normal search. Anybody know what this is? Yes. It is Microsoft's HoloLens. JPL was partnering with Microsoft to create so that you can walk on Mars. You can actually, and if you search on YouTube for JPL and HoloLens, you'll see some amazing things. That's going to be active in July at JPL. So all of a sudden, you can walk on Mars by just being at your desk. It's a very different experience, and it's fabulous. And this is just accelerating. If we had done our normal way and built it ourselves, we'd still be maintaining those, and it'd be 10 years old, and nobody would want it. 3D printing is one of those disruptors that doesn't fit anywhere. It's a key disruptor. So what did we do? About 4 years ago, I predicted that, 5 years ago, that 3D printing was the next great thing. I was dead wrong. Because I thought it went from $100,000 to $10,000, that's a disruptor. Not so much. When it went from $10,000 to $1,000, it's the cost of a laptop, and all of a sudden, people started using it. So we put it into our IT petting zoo. And an IT petting zoo is where we can get the latest technology and let the users, the scientists, the engineers, the business people, the HR people, play with it, try it, and tell us if it makes a difference in their use case. So in almost no time flat, they came up with all these new ideas of what we could do. And Chris Caprero, the person sitting down with a purple shirt, he noticed that the Mars Exploration Rover was driving on Mars, and it saw a red rock, rock with red. Red means hopefully rust. Rust means water. So the rover backed up, took a bunch of pictures, and then what he did is he took his cheap printer and printed it in pieces, and then colored it exactly the way it is on Mars. So that is Block Island meteorite on Mars, and here is a smaller copy, exactly identical. And it has Braille on the bottom so that the blind can participate. And thousands of universities or museums across the world can download it themselves for the cost of a $1,000 printer. So it's really, and it's coming down. It's quite remarkable. Smithsonian was very interested, so they asked if they could borrow it. Well, they never returned it. So it's sitting in Smithsonian, but no problem. Chris printed a new one. This is, we have an IT Expo at JPL, and really I'm showing these examples to try to show the energy that you can create. People are already doing this. If we can just find out who's doing it, we can really do a lot more. This is the Tinkerine printer, about $1,500. I'm going to show you a short video. The materials, it's about $5 worth of materials. And this is what it did. It's a hovercraft for $5. Imagine having that kit, give it to kids, and saying, all right, improve it, print it. It's remarkable. And what we've noticed is, with this JPL view that I mentioned, it took 1 hour of this up with a little stupid button to change view. Somebody said, why don't you put a touchscreen on it? I have one at home. Poof. So if you can share this with your constituents, you can get remarkable results. This is another 3D printer. Our robotics people at JPL are being snapped up by Google, by Uber, etc. So if we can give them the toys where they can experiment and have this rapid development cycle, we can keep them and we can attract new ones, and it works. So here, these are climbing robots to climb on Mars to clean solar panels, and also for various agencies to go into mines trying to find people who are hurt, etc. But it's the power of rapid prototyping. It's amazing. These things are about less than $5 worth of materials, and they just continuously prototype. It's that speed. It's from mind to something tangible, and it's looking at how animals perform. So looking at geckos, that's my favorite. Oh, how should I get up? Oh, okay. It's really the imagination that it spurs is fantastic. And if you notice, there was one that fell down. Actually, here he comes, I think. Yep, boom. That hurt. In fact, it broke all the time. So what they did is, that's, by the way, just flypaper. So you can use very inexpensive materials. Russell picked JPL over about 100 offers because we had the 3D printers. And this, afterwards, you can come up and take a look at these. This is the joint, essentially the wrist, so when the robot falls down, it doesn't break. And it's printed in one setting. So it's different materials being able to be created. And that's really the power for us. It's just, if you can get it in people's hands, they can innovate. Andy Klesch is working on small spacecraft, CubeSats. And we discovered that we could 3D print it in plastic, and they can figure it out. Then we 3D printed it in metal. 30 times cheaper, 30 times faster. And we could just hook it up and test it in vacuum changers, etc. And we can create new materials. There's no weakness of mating materials because it's printed in one setting. Very different, very much a key disruptor. Then it's about scanning. 3D scanning is another huge disruptor. And you can scan anything, including people. So very narcissistically, this is me. But come and look at it and take a look. If you can scan that, you can scan a part and fax it to the space station and repair pieces. This is a German company called Doob. And what they do is they're able to, you go in, you take a picture, 50 cameras, and immediately they upload it to a server in Germany, print it in sandstone, and mail it to you. Great for wedding receptions. But that's the power of all this technology that we can take advantage of for our smart people to prototype. So this prototyping, this very rapid experimentation, led to an enterprise architecture. An enterprise architecture that says, boy, this prototyping with inexpensive equipment really helps. Then we buy slightly more expensive printers and then the really expensive ones. But you're not wasting time on the really expensive ones. And so it can lead to something. Now, daring mighty things. Cloud and big data analytics is really the key driver to this. We are going to optical comm to space. Optical comm, going from drinking from a straw data to from a fire hose. Lots and lots and lots of data. So big data is real for us. We love the hype around big data because it means people are investing money in solutions. And risks, like this is the Sky Crane. This was the big maneuver of landing on Mars. And it worked, thank goodness. I wouldn't be here. And the rover took its giant robot arm and took a selfie on Mars. And that's the picture of the selfie to make sure that it was healthy. But what you didn't see is the behind-the-scenes story of how do we tell that story? How do we tell you that it's happening? How do we get you to care? And if you care, our servers will go sky high, and it'll break any equipment we have inside. So what we did is we partnered with cloud companies. In fact, this one with Amazon. And we were able to deliver 150 terabytes in just a few hours, 80,000 requests per second. And most importantly, very happy customers. And you saw the pictures at the same time we did. We left it running, just scaled it down, because you only pay for what you use in the cloud. Then the asteroid came and hit Jablonka, or something hit Jablonka. And all of a sudden, people logged on to see what was going on. And our server were just spiking. And so they flipped it over to the cloud infrastructure, and it handled it with no interruption of service. So then we left it there forever, for everything. Cloud is a very big enabler. So is analytics. We've come up with something called question farming. On Mars, and so think about your use case here. For us, the temperature of Mars is really the key, because instruments can only operate within certain ranges. So if we look at it, I'm sorry, I'm going to set the stage. So it's really important, but they only had on their screen. So they would take a screenshot, put it in PowerPoint, email that to the expert. The expert would look at it and say, I need this time frame, or I need more channels, telemetry channels. So we said, isn't there a better way? And the magic here is the rapid prototyping. It's treating it like a startup, saying you have 2 weeks, you have 2 people, you're completely, whatever you need, I'm here, but that's all you got. What can you do? So what could they do? They treated it like the stock market. So if you look up in the left-hand corner, there is different telemetry channels. And this is actually a movie of real time. There's 2 billion data points, 2.5 years worth of data. And they can look at it, compare all of them at the same time, just like you would your stock on the stock market. Then what they can do is they can now drill into any of these points or look at just one at a time. Like you would just look at the performance of one of your stock. This happens to be temperatures. Then what they really want to see, they want to see those highs and the lows. So they look at the trends. And now, again, there's 2 billion data points. They can zoom in on what they want. And instead of emailing a PowerPoint, they email the situational awareness. They email to the expert, who might be on a beach somewhere, hopefully. Why don't you continue the analytics from here? And all of this is in real time, and they can pick any of those points, zoom in on it, points of interest. Then they can click on that particular point, and they can see all the messages that was generated by the rover. There's 26 million of them right now. They can see if that message has occurred before. And once they have done that, they can also look at what was happening on Mars at that exact time. So these are the pictures that were taken exactly at that moment. So instead of the person being slave to the data that somebody had decided they could get, they could now drill in and do their own analytics. The most powerful analytics computer is what? Not mine, but yours. And so if you can do the visual analytics, it's really powerful. So question farming, ask a question, visualize it, go back and say, does this explain anything? And just very rapid iteration has led to wonderful things. The other surprise was we said, I'm the CTO, so I know a bit about technology. I said, use whatever you want, whatever technology you want. And they picked things I'd never even heard of. So if I had said, you shall use this technology, we would never have gotten there, because all of the open source that Christian talked about earlier today, it's real. So if you look at these and think about how many of those do you feel comfortable explaining to your grandma. And it's amazing. But the key to all of that was creating an analytics cloud. A cloud where we copy the data comes down from space into these systems that are full, into the analytics cloud, where we can experiment without risk to the main mission. So that's really the power. We ported it to another spacecraft in 2 weeks, and it worked. It worked because we had used an open development environment. So another developer said, oh, I can take this and use it without asking anybody for permission. It's open inside JPL. And he was able to port it in 2 weeks. And it saved the launch of SMAP, actually, because they looked for the trends. They found a bad pattern. They looked back at the test data and saw that it happened before, so it was OK. So they were able to launch. So these small prototypes can lead to huge things. What's really important is to reward the innovators. So you partner a passionate end user, Gordy on the left, with a passionate developer, Dan on the right. One is from IT, one is not. And here comes the magic. IT is no longer information technology. It's about innovating together. And it's a two-way. So, and it creates fantastic opportunities. Our finance guy said, all right, that's good. What's the cloud doing for me? So here what you can see is in 2007, these are actual data points. We looked at our bills. We've been in cloud computing for about 8 years now. And looked at it and said, okay, we can actually, it's only CPU power that matters. The storage is a minor part. So how much has it gone down? The power, the red curve, has gone up 100-fold over those years. The amount of CPU power you bought for each dollar has gone up 600 times. So what does that mean? Imagine if we had bought those computers in 2007. We'd be losing out on 100 times performance and 600 times cost effectiveness. So the cloud is a very cost-effective place to play. It really is the enabler. Next IT decade. So now this is where we start really thinking and playing. And you're seeing it in the very beginning. You're seeing the sauce being made here. So we think that these are the key pieces. There's two pieces to it. There's human behavior. Human behavior changes a lot slower than technology. Technology is fast, but will people adopt it? So this is what we think will happen in the human behavior side. IT commercialization is taking advantage of all of these things coming out of Silicon Valleys in every country. Internet of Things, rapid prototyping, and much faster work cycles. In fact, the startups are going to continuous release all the time. No build it, test it, deploy it. It's all the time. And can we do that in the enterprise? Data. Data is the new currency. It's no longer money. Money is the CFO's domain. Data is the CIO's domain. So applications will be throwaway, temporary. Data is permanent. It's a very different way of thinking about it, and that drives an enterprise architecture. In fact, we think it drives a chaotic architecture. Chaotic architecture says you have to have an architecture, but it's going to change from underneath you. So if you plan for it, you'll be okay. It's a huge disruptor. NUI. Anybody know what NUI is? Natural user interfaces. No longer are we typing. We are swapping. We are tapping. We're almost tapping with near-field communication. We are speaking, and soon we'll be thinking. One of my NASA friends actually showed a demo of landing a rover by thinking. So it's coming. Disruption everything is, here's the IT pieces, and you will have these slides so you can look at it in more detail to see if you agree. And if you notice at the bottom there is some Google Docs. We would love to get everybody's feedback and say, what do you think? So it's open for everybody to edit. But Internet of Things is a really big deal. So let's take a look at what Cisco thinks Internet of Things look like.
This is the cat that drank the milk and let in the dog that jumped on the woman who brewed the coffee.
Brew coffee.
That woke the man who was late for work.
All right, I gotta go.
and drove the car
Driverless mode engaged.
that found the parking spot
Find parking space.
Parking space found.
that alerted the door that opened the control room,
Hey, Bob.
that secured the data, that directed the turbines, that powered the sprinklers, that watered the grass, that fed the cow, that made the milk, that went to the store, that reminded the man to buy the milk, that was poured by the girl who loved the cat, that drank the milk. The Internet of Everything is changing everything. Cisco, tomorrow starts here.
It's a cute and fun movie, but do you see all the technology that was in there? All of that is going to penetrate the enterprise, and we've got to be ready. This, of course, you can read every single word here, is a realization that I looked at the, this is the Internet of Things ecosystem, and I looked at the patents coming out in the US since 1700s. And they're going sky high of new things, and then they tailor off right around now. They taper off. But do you feel like we're in an area that stopped innovating? Not so much. But if you look at combinations of things, existing things creating new uses, the patents are sky high. So it's really about combining things on this list will create new capabilities for us. And it's much, much faster to do that. That's what the startups really do. Chaotic architecture. Really, the key to this is that looking at emerging trends and being ready to adopt them through a prototype approach in our enterprises will keep us from being disrupted from things that we haven't thought about. So our recommendations is simply that you maestros are going to be directing the IT continuous. And we call this new era the disruption of everything. It's all of those new things are entering the enterprise. So what we think is learn from others. These are 3 really powerful books. In particular, Makers by Chris Anderson. It's about the new maker movement. He makes a very compelling argument that the last 10 years have been about building infrastructure. The next 10 years is going to be about using that. So the innovation will go even higher. The path forward is to measure what works in your organization. For us, it's rapid prototyping. It is open development, hardware and software. It's really cheap, so you can experiment very rapidly. Renewed focus on data. It's non-traditional relationships. We've, with the cloud, we were one of the first enterprises. It was very difficult to get the cloud vendors, the commodity cloud vendors, to think about us, not as a person with a credit card, but as an enterprise. So we were able to educate them and ourselves. In doing so, we partnered with facilities, with legal, with procurement, in new ways. And that's paid dividends big time since. So it's not only outside. Who would have imagined that a bookseller would give us all of our infrastructure in IT? Who's next? 10 years from now, who will be the big ones? So really, the strategy here is rapid prototyping, finding a moment of engagement where somebody cares. And don't measure return on investment, because you won't get it, but measure return on attention, where the end user says, wow, this is interesting. And you know you have a hit if when you say, good, you give them something that they can actually look at, and they will fund the next phase. If they don't, we drop it, because there's so many opportunities. 2025, what will we look like? Self-driving cars. Who agrees with me that we will have 10% of our cars be self-driving in 10 years? And if you don't, have you ever had to take the car keys away from your parents? And the aging population? For me, I'd much rather have it go and have a self-driving car and say, take me home. I don't remember where home is, but take me there. It's a much better world. For us, we will be going to where there's most likely to have life in our solar system, Europa, the moon of Jupiter. We'll be capturing an asteroid so we can understand how asteroids work, so when the big one comes, we can deflect it. And we'll be well on our way sending humans to Mars and get them back. And if you visit JPL, it will look exactly the same on the outside. But on the inside, it's going to look very differently, because we will work differently. So that's all I had. But we have the toys, and we have all these cards if you want to have your own augmented reality show for your kids. I tell you, you will be the most popular parent at school. They love playing with this. We strapped it to our dog, etc. It looks like they are actually eating the rover. They're hugging it. It's fun. For us, it's outreach. But if you think about how engineering will work, you can actually see what it should look like when it's finished and overlay it to how it's done now. You can see how the joints work, etc. Whatever the application is in your world, it's truly a disruptor.